Magnetic field of the Earth and its variations. All the magnetic measurements are made in the magnetic field of the Earth. Therefore, it is necessary to have a thorough understanding of the Earth's magnetic field, and its contribution to the measured magnetic effects. The magnetism of the Earth have been studied for centuries. Extensive measurements of the magnetic elements have been made at sea, because of their importance in connection with the use of the magnetic compass for navigation, and also on land in connection with the use of the compass for surveying. Long-time studies of the magnetic elements have been made at magnetic observatories on land to study slow, or secular, changes in the Earth's magnetic field. The Earth's magnetic field resembles the field of a large bar magnet near its center, or that due to an uniformly magnetized sphere. The origin of the field is not well understood, but thought to be due to currents in a fluid conductive core. The field, or flux lines of the Earth exhibit the usual pattern common to a small magnet. The first recognition of the fact that the direction of a compass needle deviates from the true north, the deviation now being called declination, by placing a small magnetic on a spherical lodestone, it is confirmed that the inclination of the magnet changes over different parts of the sphere. The magnetic deep angle with increasing latitude was confirmed based on studies. Geomagnetic phenomena are closely related to those in other fields of geophysics. The understanding of the origin of the Earth's main magnetic field was helped by the knowledge on the structure of the interior of the Earth, which had been gained mainly by seismological studies. Direct aerial measurements, and observations of solar radiation by rocket techniques, have greatly advanced our knowledge of the physics of the ionosphere, which forms an important background for geomagnetic researchers. Now, let us considering the Earth magnet. The phenomenon that the planet Earth possesses a magnetic field, dipole in character, is a scientific revelation brought forth to the world by William Gilbert as early as 1600 AD in a scientific treatise called The Magnet. It is interesting to know that the Earth's magnetic field resembles the field of a large bar magnet near its center, or that due to a uniformly magnetized sphere. On the surface of the Earth, the pole of this equivalent bar magnet nearest the north geographical pole is actually a south magnetic pole. This paradoxical situation exists because, by convention, a north-seeking end of a compass needle is defined as pointing north, yet must point to a pole of sight sense, or south pole of the Earth's magnetic field. So, to avoid possible confusion, though the magnetic pole near the geographical north pole is south magnetic pole, it will be referred to as a north pole. Note that the direction of the field is vertical at the north and south magnetic poles, and horizontal at the magnetic equator. As understanding of the geometry is important with respect to interpretation of magnetic anomalies. Let us know about the elements of the Earth's magnetic field. If a magnetized needle is freely suspended, or allowed to move freely on a pivot, it becomes inclined with the north-seeking pole of the needle, dipping downward in the northern hemisphere. The angle in which the needle makes with the horizontal is called the deep or inclination, I. Inclination is reckoned positive if the needle dips downwards, as is the case in the northern hemisphere. If the magnetic needle is approximately balanced for the inclination, and allowed to swing in a horizontal plane on a vertical axis or pivot, the needle aligns itself in a direction with the north-seeking pole, showing the Earth's magnetic north. The direction in which the magnetic needle aligns is called the magnetic meridians. However, the magnetic meridian at a place differs with the geographic meridian by a small angle. This deviation is called the declination, d. The fact that the geomagnetic poles are not the same as the geographic poles gives this difference. The rotational axis passes through the geographic poles, whereas the magnetic axis is the line joining the magnetic poles of the Earth. If the deviation is east of the geographic north, the declination is considered as positive, and if it is west of the geographic north, the declination is considered as negative. In other words, declination is defined as the angle between the magnetic and the geographic meridians at a place on the globe. Following the same figure in which the magnetic meridian is the vertical plane, which is passing through the total magnetic force, F, the declination, D, and the inclination, I, completely define the magnetic field at any point on the Earth. The total force vector, F, of the Earth's magnetic field can be resolved into vertical, V, and horizontal, H, components. The horizontal magnetic force, H, can further be resolved into X and Y components in the direction of geographic meridian and its orthogonal component. H is always considered positive whatever its direction, while V is reckoned positive downwards having the sign convention same as I. The X component is positive if northwards and Y positive if eastward. The geomagnetic field components discussed above are in a simplified manner. But the practically located poles by actual measurement of 90 degrees deep on both hemispheres are not diametrically opposite, and do not have the same pole strength. The North Deep Pole in the Arctic region is located at the geographic coordinates 75.5 degrees north and 100.5 degrees west, with a strength of about 0.6 Gauss, and the South Deep Pole at 66.5 degrees south and 139.5 degrees east with a strength of 0.7 Gauss. It is important to note that the deep poles are not same as the geomagnetic poles, which are best approximated to the Earth's field and meets the Earth's surface at diametrically opposite points. These are situated at 78.5 degrees north, 69 degrees west and 78.5 degrees south, 111 degrees east respectively. The imaginary line joining the 0 degrees deep value around the Earth is called the magnetic equator, and this has been established around the world. This magnetic equator is not the same circular as the geographic equator, which we commonly come across in the maps of Atlas. But it is a zigzag line around the Earth cutting sometimes the geographic equator. The last topic is about the magnetic charts and maps. The global-wide changes of the magnetic elements are shown in isomagnetic charts. These isomagnetic charts or isomagnetic maps are nothing but the contour lines drawn through points of equal values. The isomagnetic contours of the magnetic elements, X, Y, V, H, and T, are called isodynamic lines. However, the following names are given for each chart. Contour of equal values of declination, D, and inclination, I, are called respectively the isogonic and isynclinic lines. All these maps are prepared on the basis of the data obtained from the magnetic observatories, located in various countries in the world, and from the oceanographic cruises carried out specially to measure these elements.